Let's try and find out amplitude for resultant waves produced due to superposition of two waves. Alright, now two waves are moving in this way with equation a sine omega t for y1, and for y2 it is a2 sine omega t plus phi. There's a phase difference or epoch of phi. So this starts from origin and this starts from slightly above origin. Alright, so already it has some displacement before it starts, and in terms of phase it is phi or epoch. Alright, so that's the reason why we have here phi. Okay, now these two waves y1 and y2 have same frequency. Frequency is hidden in omega. Why? Because see, we know omega is equal to 2 pi by t, and t is time period and 1 over t is frequency. Alright, so what we mean to say is that omega here and omega here is same. If I call this as omega 1 and call this as omega 2, omega 1 would be equal to omega 2. That's what I have clearly mentioned over here. Alright, for your understanding. So that's one thing. So omega is same, or rather frequency is same, and amplitudes are different. A1 and A2 are different amplitudes. Alright, now, so the equation y1 is equal to a sine omega t, already mentioned. Y2 is equal to a2 sine omega t plus phi, already mentioned. Phi I explained is the phase difference. Now both waves have same frequency, which I already explained. Alright, according to principle of superposition, for two waves starting together, x is equal to 0 obviously because it's starting, and both are starting together, so displacement also is 0 for both the waves, so x is equal to 0. The equation would be y is equal to y1 plus y2. Y is equal to, so now what we do is we substitute those values over here. Alright, so y is equal to a1 sine omega t plus a2 sine omega t plus phi. Now for sine omega t plus phi, we apply formula for sine a plus b. Alright, so what we end up is with a2 sine omega t cos phi plus a2 cos omega t sine phi. Now when we check out these two, we have sine omega t common over here, so we take sine omega t common out of the bracket, and what is left inside is a1 from here and a2 cos phi from here, and here we have a2 cos omega t sine phi. Furthermore, what we do is, now we do a bit of substitution. Now in case of substitution, what we do is a1 plus a2 cos phi we substituted as a cos theta, and a2 sine phi we substitute as a sine theta. So what is left from here? So we have got this as a cos theta, and this is left here as it is. Now here a2 sine phi goes in as a sine theta, and cos omega t is left as it is. This again refers to formula sine a plus b, so we condense it to formula a sine omega t plus theta. Now this is the resultant wave equation. Now in this equation, the frequency which is hidden over here, 2 pi by capital T time period, and 1 over time period is f, or 2 pi f. So frequency which is hidden here is f1 is equal to f2, that is frequency of first wave is equal to frequency of second wave, and now the final resultant wave frequency is also same, so f. So same frequency or time period as that of interfering waves. Now let's derive equation for resultant amplitude. Alright, for resultant amplitude, we already have substituted a cos theta is equal to a1 plus a2 cos phi, and for a sine theta we had substituted a2 sine phi. Now we square this. So on squaring this, we get a square cos square theta, a1 plus a2 cos phi the whole square, and similarly here also we get the square. Then we add it up. On addition, we have LHS added and LHS added and RHS added. Alright, so here we can take a square common. So what we are ending up with is cos square theta plus sine square theta, which is equal to 1, and here a1 plus a2 cos phi square, if we expand it, it gets to a1 square plus 2a1 a2 cos phi plus a2 square cos square phi plus this remains as it is, a2 square sin square phi. Now again here if we take a2 square as common, then it would be cos square phi plus sin square phi, which would be 1. So instead of this, we can jot down a2 square. Alright, and this remains as it is even in the final equation, and this a1 square, and this already we saw this had become 1. So this is a square is equal to, that's the final amplitude square, is equal to root of wave 1 amplitude square plus 2 into product of two waves amplitude cos phi plus wave 2 amplitude square. So this is the equation to be kept in mind. Okay, now we are going to apply this equation for special cases when phase difference would be 0, when phase difference would be pi by 2, and when phase difference would be pi. Alright.